Hello students, so last video session I had told what are the functions that we are going to do or what operations are we going to do in the linked list. We listed out all the operations and we started writing a simple, the initial lines of the code we have already written. Let us take each function one by one. The first one that we are going to see is why the insertion at the beginning. So how do you insert a node at the beginning of the linked list? Okay, so let us say, of course, you have start pointer. This is the start. As I said, start is a pointer which is going to hold the address of the first node. Okay, this is there. This, suppose I have entered some 30. This is my second node. I have some 41 there. And then I have the third node, let us say, and then I don't have, it is a null pointer, so that indicates the end of the linked list. Okay. Now, if I want to insert in the beginning, this is what I want to do. What is it? First, let me put down int value. I will take one variable int value. Value is where you are going to accept what you want to insert. Okay. So, let me say cout, enter the value to be inserted. Right? So, cin, I will accept the value that I want to insert. Okay, I have accepted the value. Next, what I do, I will take one pointer of the type node. Node star 10. Okay, this is equal to new node. That means what? In the last video session, we have seen what is new. New is going to allocate the memory that is required for this temp. Temp is basically the new node that I want. This I call it as temp. New node that I want to insert. Okay, this is my node. So since we are taking it of the type node, what is node? Node is a structure. We have already defined it in the previous video. Just go through if you are getting confused. Node is nothing but a structure. So temp is we are defining it of the type node. Node is a structure. So whatever is there in that structured node will also be applicable to temp. Alright. So node star temp is equal to new node. Why am I using this new operator here? That is for allocating the memory for this particular node. Alright. Now, so as we know, temp has got two fields. One is we define it as, when we define the structure, we define it as data, and then we define the next pointer variable as next. Right? We have done this. So let me say, enter the value to be inserted, cin value. Some value, let us say I want to insert 22 is the value I am accepting here. Okay. Let me keep my node ready. So how do I assign that? I will say temp of data is equal to the value. Why? Because temp of data is value means this is your data part. Okay, this is the next. That is the address of the next node, pointer variable. So whatever I have accepted to be inserted, that will come in the data part. How do I access it? I will use this arrow in order to access the members of the structure. Right? All of you know that. So temp of data will be value. So here I will store my value that I have accepted, which is 22. Next, what will be this? Right now this is a single node. I am not going to put in anything there. So what can I write that as? Temp of next is equal to null. So my node as such is ready. I want to insert this node at the beginning of my linked list. Alright, so that is what I am going to do. Now, before I insert, what should I check? See, I said this is my linked list. This is one of the possibility that it is a linked list and I will insert at the beginning, means my first node should come this one. But there can also be a possibility wherein my linked list can be empty. Correct? Linked list is empty. Even then I may want to insert at the beginning. So what will happen? Whatever node I want to insert will become the first node. That is also possible. Is it not? So always you should check if your linked list is empty or not. If it is empty, you are anyways going to insert that node at the beginning, or that will become your first node. If it is not empty, then I will have to make some changes. Here, first I will go for if it is an empty case. How do I check if my linked list is empty or not? We already know that we have, if the linked list is empty, start is going to point to null. Correct? So I will first check if start is equal to null. Start is null means what? It is empty. Correct? It is empty, so this node itself will become the first node. Then start itself, start is equal to temp, start of next will be equal to null. So temp will become my new start. That means why you are saying start is equal to temp. What is start? Start is a pointer which should hold the address of the first node. So this will become my first node, because if start is going to be null. Start is null means what? Linked list is empty. So if it is empty, this will become my first node. So temp start is equal to temp. So start is equal to, this is my temp here. Temp of next will be equal to null. That is, start of next will be equal to null, because that is the only node that you have inserted. Right? Else. I will take an else condition here. Else means what? Linked list is already there with some nodes, but I want to insert at the beginning. What can we do? Let me take a else condition. Else means what? Start is not null. Start is not null means what? This linked list is already there with some nodes. You want to insert this new node at the beginning. Correct? This node should come here. So what should I write? See, it should look like I have start here. This should point to the first node should come there. And then 22, this will point to my next node, 30 and so on, 41 and so on. Okay, so what can I do? I can write, what will be my start? Start is pointing where? It is pointing to this location. So now, I'll probably show it to you in a different way. I'm just rewriting that so that your understanding becomes easy. This is what is existing. This is what is existing. List is not empty. Because if start is null, new node becomes the first node. That part we have done here. Else I have taken here. Else means what? Start is not null. Start is not null means it is pointing already to some nodes. Some nodes are already there. It is pointing already to this particular node, which means it is not null. Now, in this case, if I want to insert at the beginning, okay, this has to come here. This temp what I have done, this is my new node, correct? So this temp of this node should come here, correct? And this should point here. That is how you insert it in the beginning. This should come before your 30, and your start should actually now point to 10. So what can I write this as? This see, look at here. I am pointing, this is coming here. What is this? How do we access this? This is nothing but temp of next. Correct? Now this temp of next, where are we pointing it to? This location. How do we access this location? It's nothing but start. So else I can write temp of next is equal to start. Are you clear? should not anymore point to 30 because that's not the first node. 22 becomes your first node. So what will happen? This pointer should not be null now. It should be pointing to the second node. How do I access this node? This node is nothing but currently it is the start. Okay. So temp of next will become start. What will be the new start? New start will be your temp. Because this temp will, whatever you are adding will become the new start. So your start is equal to temp. Alright. So that is how you are trying to insert the element at the beginning. Am I clear? I hope I am clear to you. So else this condition, and then probably you can give a cout. Element is inserted at the beginning so that you know this part has got executed. Okay. And close that. This is how you try to insert at the beginning. Let me tell you again. I said we are first taking a node, temp as a node. So temp is my new node. How did we declare this temp? Node star, node star temp. Okay, that means what? Temp is a node which is of the temp is a pointer variable which is of the type node. Node is what? Node is a structure, correct? Which contains data and next as the two fields, correct? So temp is my new node, and I am accepting. We have written say in value. You are accepting what value you want to insert. So I want to insert 22. Okay, first I will keep this new node ready. That means temp of data is 22. Temp of next will be null because I am just keeping one node ready. This node, I want to insert it at the beginning of the linked list. So that is what we are doing, insert at the beginning. Now, whenever I want to insert at the beginning, I have to first check one condition whether the linked list is empty. If the linked list is empty, then this will become the new node. This will become the first node. You are inserting at the beginning, you are inserting. That's the only node you are going to have in the linked list. So how to check whether it is empty or not? If start is null. When will your start be null? Start is what? It is a pointer which is pointing to the, which is holding the address of the first node. So as long as you don't have any nodes in the list, this will be pointing to null. So if start is null, then this temp will become the new start, right? So start is equal to temp, start of next will become null. Alright, so that is how you write. That means this is only node now in your linked list. The other option, else, your linked list may not be empty. That is, your start is not equal to null. When it is not equal to null, when it is already holding the address of a first node, then it is not null. It is already holding the address of the first node means what? Some element is already there in the linked list. We have to put this new node before this. That's beginning, is it not? So what will I do? If I have to bring in this node here, this is the temp. This should point to, this becomes the second node. This becomes your first node. And this will become your start. So how do I write that? Temp of next. This is my temp of next. This should point to this node, is it not? How do you get the address of this node? It is nothing but currently start is already pointing to that. So temp of next is equal to start. Start becomes the temp becomes the new start. So start is equal to temp. And then you give a display statement so that you know all these are executed and you come at this point saying this particular element has been executed. Element has been inserted. This is how you insert at the beginning. Okay. Now next let us see how we can insert at the end. Okay. Now let us see how we can insert at the end. I want to insert the node as the last node of the list. Okay, again you have to accept first what you want to insert. So int value, I will declare one variable. Let's say cout. Enter the element to be inserted. All that you can write. So cin, I am accepting the value that I want to insert. Okay. Next what? I should create one node is equal to new node. That means I am requesting for allocating memory to that node. Temp is a new node that I want to insert. I will take one more pointer variable. Let us say yes. I will tell you why I am. Okay, so this is the new node. Temp is my new node. Okay, so what will be temp of data? Temp of data is whatever value you are going to accept. Let me say I have accepted 15. So temp of data will be, I'm sorry, not 15. Here I should put it as value. And this is null. So that I can write it as temp of next is equal to null. So my node is ready to be inserted. Now where should I insert it? I should insert it at the end of my linked list. Okay. Now again, if I have to insert anything in the linked list, again I have to check whether my linked list is empty or not. If it is empty, same thing as we did in the for insertion, I have to anyway insert this. Beginning or end doesn't matter because that's the beginning, that's the last, that will be the first node, that will be the last node also. So again I have to check if linked list is empty. How do I check? If start is equal to null. Start is null means there are no elements in the list at all. There are no nodes currently. So this node itself will become the first node. Since there are no nodes, this will be the first, this will be the last. Correct? So the same thing what we wrote for insertion will come here also. Start will be equal to 10. Then what do you write? Start of next will be equal to null. That's the only element. New start. Temp will become your new start. Okay. Not new start, start, because you don't start as null now. So this is what you do. So this element will now become the only element, only node in the linked list. Okay. Next, else. That means if the linked list is not empty, I have a start pointer. This is pointing here. I have some elements. This is how my linked list looks. Now, I want to insert this node at the end here. That means this null pointer will go now. Correct? This will now point to this one. Correct? And this will be anyway null. Right? That is how we should link it now. Let us see what we can write. So I will take an else here. So else condition is what? List is not empty and I have to insert this temp at the end. Now, whenever we I should come up to this node, is it not? What is the after this last node I want to insert this. So I will have to find out which node has this null. That is an indication for me to know that it is the last node. But I can't jump to that node, is it not? I will have to start from here only. That means I know the address of the first node, which is in start. From here I have to traverse all the nodes to check next of which node is null. Next of which node is null is this. Till here I should come. Then only I can insert this. Correct? So how do I traverse? I will take this pointer s is equal to start. Then I put the whole thing into a loop. I have to check whether the next of this node is null or not. No, it is not null. That means you have one more element. Again I will check. Next of this node is null or not. It is not null. That means you have one more element. Next of this node is null or not. It is null. That means that is the last node. You have to arrive at that, is it not? Only then I can put this node, link this node to that. So what I can write? While I start from start, this will become yes. S is equal to start. While s of next is not equal to null. Are you getting? S of next. This is my S now. S of next is what? This one. Is it null? It's not null because it is pointing to the next node. Okay, what should I do? It is not. It is not equal to null means what should I do? I will simply write S is equal to S of next. That means I have to go further. Is it not? This is my S. S is equal to start. S of next, is it null? It's not null. While S of next is not null, what you should do? S is equal to S of next. So this will become my S. S of next is what? S is equal to S of next. This will become my S. Again, S of next, is it null? It is not null. Again, I will go to this. S of next, is it null? It is null. Okay, so I have to bring this. How can I write that? Now, S is equal to S of next. You will stop at this location, correct? This will become your S. Once this condition is satisfied, it will come out of the loop. How will you code this now? S of next should be equal to your temp, correct? S of next is null here, but we don't want null because we are trying to link this element. This should point where now? It should point to this. This is what? Temp. Temp of next is what? Null. That we have already written before. Okay, so what should I write here? S of next will be equal to temp. That is your else part, and that's how we insert at the end. So first what we check when we try to insert, we check if the linked list is empty. How do you check if S is equal to, if start is equal to null? If start is equal to null, then you are simply inserting it. That becomes the first element, last element, everything is same only, node. If it is not null means you have some elements in the linked list. You have some nodes in the linked list. But you have to traverse until you reach the last node because you want to insert at the end. Correct? How do I come up to the last node? So I will take one more pointer, initialize it to start, and from there I will traverse each node. How do I check? I will check whether S of next is null or not. Null or not, why I am checking this? Because last node will have this S of next as null. Correct? We have seen that. So here I start from here. I initialize this node as S. S of next, is it null? It is not null. Is this null? It is not null. Is this null? It is null. Moment it is null, it will come out of this loop. What you should write? This S of next should now point to temp. That is how you insert the node at the end. Am I clear? So we have seen two functions: insertion at the beginning and insertion at the end of the single linked list. Okay, other functions I will take it in the next session. I will see you all in the next session. Thank you.